All right, so if I drew a heads, then what could happen? I roll the dice and I roll a what? Great. I'm sorry, great. Tails, same thing, right? And then we have our sample space. Actually, I'll go ahead and do it this way. It's faster. So here's our sample space. Yes. And we can also use these to find probabilities. We can write the probability of each outcome along the branch. If I'm going to do that, I should probably remove this part here. So 1/2 chance of heads, 1/2 chance of tails, 1/6 chance of each one of these. Good? Okay. And please note, like, these always have to add up to 1. These should all always add up to 1, right? Anything that comes off of there? So how do I find the probability of, we said it was heads, then a 4. So heads, then 4. We're going to take their probabilities, and we're going to multiply them. 1/2 times 1/6. When you multiply fractions, just to give you a reminder, in case you've forgotten, you multiply fractions, you multiply the numerators, and you multiply the denominators. So 1 times 1 is 1, 2 times 6 is 12, 1/12. Let's take a look at it here. Here's the example. In this case, they're independent. So the probability of head and 4 is just the probability of heads times the probability of rolling a 4. Probability of a head is 1/2, 4 is 1/6, multiply them and you get 1/12. You can also do it using the sample space. Right, there's 12 items, 1 equally likely. One of them is a heads 4, so 1 out of 12. It works in this case because they're equally likely. That will not work in cases where they're not equally likely, which we'll get to pretty soon. In general, trees are super useful, especially when probabilities are not the same. So here's a situation. I have, imagine white is blue. I have 6 blue marbles, 6 white marbles, and 3 red marbles. I'm going to draw a marble, look at it, and replace it, and then draw another marble. Since I replaced them, these draws are independent, right? The probabilities don't change. So what's the probability that my first draw is red? 3 red marbles, 6 blue. What's the probability my first draw is red? 3 out of mine, not yours, mine. This is not on your sheet, this is only on my sheet. 3 out of 9. 1/3. So don't do this on yours because yours is different than mine, incidentally. What's the probability I draw a blue marble? 6 out of 9. I'll reduce that to 2/3. And then if I drew a red marble, I draw again. What could happen? What could I draw? Red or blue? What's probably I draw a red one?
3 out of 6, or 3 out of 9.
3 out of 9, so that's 1/3. What's probably I draw blue?
2/3.
2/3. 6 out of 9, so 2/3. What about if I drew a blue one first? What could I draw for my second draw? Red or blue? Probably of red. Oops, red or blue? Probably of red. 1/3. Blue. 2/3. Good. Then, if I look at these, say I wanted to know how to end up here. I go here to red, there to blue. I multiply their probabilities. 1/3 times 2/3. 1 times 2 is 2. 3 times 3 is 9. 2 ninths. Everybody on board with that? Notice a couple of things. Let me do this down here, I guess. One thing is that all of these that equals 1. Anything where it branches off, those should add up to 1. Here it branches again, those should add up to 1. These should add up to 1. Everybody follow that? Also, at the very end, the grand scheme of things, that also adds up to 1. This adds up to 9/9. So that's also 1. Those should all add up to 1. Here they are for each piece, right? So like this one here is 1/3 times 2/3. This one is 2/3 times 2/3, 4/9. Everybody on board with that? So I need you guys to focus just for 30 seconds. This is kind of the easy way to explain it, if it's still kind of confusing. I like to think of it as a river that's flowing. So here's my river that's flowing. I'm bouncing down this river. Eyes here, guys. I'm going down this river. The river branches. 1/3 goes to red, 2/3 goes to blue. So I'm going towards red. This 1/3 is going towards red. It branches again. 1/3 goes to red, 2/3 goes to blue. But this isn't 1/3 of the whole river. It's 1/3 of 1/3 of the river, right? Because I already branched once. So 1/3 of 1/3, that's how you get here. Right? 1/3 of the river's gone here. 1/3 of that third has gone there. 1/9 of the river. Of means multiply. So if I wanted 3 of these and they cost $2, it wouldn't be 3 plus 2, it'd be 3 times 2. $6 I need to come up with. Right? Of means multiply. So 1/3 of 1/3, 1/3 times 1/3, 1/9. And remember, multiplying fractions, you multiply the numerators, you multiply the denominators. So in light of that, why don't you guys do lab problem 4. How are we so far ahead of the other classes? You guys are super fast. Yeah. All right, so take 5 minutes, I'll give you 2 whole extra minutes, to do this problem, and then we'll go over it. All right, so what's the probability I draw a red marble?
3 out of 10.
What out of 10?
3 out of 10.
3 out of 10? Great. What's the probability I draw a green one?
1 out of 10.
And a blue one?
6 out of 10.
6 out of 10. Great. Now, if I drew a red marble first, what could happen on the second draw? Red, green, or blue? Probability of red?
3 out of 10.
Green?
1 out of 10.
Blue?
4 out of 10.
6 out of 10. Right, because I replaced it. It's exactly the same. How about if I drew a green one first? Then what could happen on the second draw? Same thing. Red, green, blue. 3 out of 10, 1 out of 10, 6 out of 10. What about a blue one? If I drew a blue one first, then I could get a
3 out of 10.
yeah, red, green, or blue again. So red, green, and blue are my outcomes. The probability of those outcomes are 3 out of 10, 1 out of 10, and 6 out of 10. Good. Now, the question is, what's probably I draw red on the first draw?
3 out of 10.
3 out of 10. Everybody's on board with that part, right?
Yeah.
What's probably I don't draw red on the second draw?
7 out of 10.
So it's independent. The second draw is exactly the same as the first draw.
So it's just complement, 7 out of 10.
It's just a compliment, 7 out of 10. Make sense? I like the way you said that. 7 out of 10, compliment. How about red then blue? So that means I went red and then blue, this path this way.
0.18.
Which means I'm multiplying what? 3 out of 10
10. 7
times 6 out of 10. Everybody on board? And again, when you multiply fractions, you multiply the numerators and the top, and you multiply the bottom. So the top is 3 times 6, 18. The bottom is 10 times 10, 100. So 18 out of 100. Don't leave it like that, that's fine. Good? Everybody all right with those?
Yes, ma'am.
Awesome. So we are going to leave 10 minutes early.